For as long as people have looked up at the stars, we've wondered what lies beyond. The night sky isn't just filled with points of light, it's filled with questions. Where do the stars lead? Could we ever visit them? Could we leave our home behind and travel to another part of the universe? These questions have lived in us for centuries, passed from voice to voice, from dream to dream. And though we've built rockets and telescopes, the answers are still unfolding. The truth is, space is larger than most of us can imagine. Even the smallest parts of the universe are too wide for our senses. Light itself, the fastest thing we know, takes over 4 years just to reach us from the nearest star. That means if we traveled at the speed of light, a speed we can't yet reach, it would still take 4 years just to arrive at the closest place outside our solar system. And most stars are much, much farther away than that. Our galaxy, the Milky Way, is so large that it would take 100,000 years for light to cross from one side to the other. And the Milky Way is just one galaxy among billions in the observable universe. Each one holds its own stars, its own planets, its own stories we can't yet hear. We are not trapped on Earth, but we are held close by the distances between everything. Even with the best tools, those distances remain. The dream of traveling to the stars is not impossible, but it is far more difficult than most people realize. It is not just a matter of building a faster rocket or inventing a new engine. It's not just about courage or vision. The limits are not emotional or political. They are physical. They come from the nature of the universe itself, from the way light moves, the way energy works, the way space stretches. Some people imagine that with the right invention we could leave our solar system tomorrow, that we could step into another galaxy the way we step into an airplane. But the reality is slower. Every mile we cross into deep space brings new challenges, not just in speed but in survival. In the silence between the stars, technology is only part of the story. Time, distance, and physics are the true barriers. And this leads us to the central idea of this journey. There are limits, real, natural, unchanging, that keep us in our galaxy for now. They are not faults in our machines or failures of imagination. They are truths built into the fabric of space and time. And understanding those truths doesn't make our dreams smaller. It makes it deeper, more grounded, more human. Because we are learning not only how far we can go, but why going far is so hard. So in this series, we'll explore those limits, not as problems to be solved quickly, but as the quiet boundaries of what space asks from us. We'll look at the limits of speed, the challenges of energy, the needs of human life, and the ways time stretches and bends across the stars. We won't rush. We won't pretend the answers are simple. We'll move gently, with calm, through the true size of the unknown. Even if we could build a ship that travels faster than anything ever made, that would only be the beginning. The speed we need to leave the galaxy is far beyond what any fuel can support. The energy it would take to reach even the closest stars is so great that no single planet could carry it. And once we arrive, we would need to live there, forever changed by the journey. This isn't science fiction. This is real. So many of our space dreams have been shaped by stories, of ships that bend space, of wormholes and warps, of shortcuts that let us leap between stars in seconds. But these stories are just that, stories. They help us imagine, but they don't change the nature of space. In real space, everything is spread wide. Everything takes time. And in most of the universe, there are no shortcuts at all. But that doesn't make space any less beautiful. In fact, it makes it even more mysterious. The galaxy is not close to us out of cruelty. It is distant because it is wide. And that distance gives us time to think, to learn, to prepare. The stars are not ignoring us. They are waiting patiently, quietly, shining across the miles with no judgment and no rush. In a way, the slowness of the universe teaches us patience. It reminds us that we are still learning, still growing, still small. And that's okay. There's no shame in smallness. In fact, there is peace in it. We don't have to conquer the stars. We can begin by understanding them. And through that understanding, we can know more about ourselves. There is a kind of respect that comes from knowing our limits. It's not defeat. It's not giving up. It's the quiet strength of facing what is real and choosing to move forward anyway. Space doesn't need us to be fast. It asks us to be careful, to be humble, to be steady. And that kind of journey, the slow, thoughtful kind, is still ahead of us. So we begin with this thought, that we live in a galaxy full of stars we cannot yet reach. Not because we lack hope, but because the path is long. And in this long, quiet path, we find a new kind of beauty. Not the thrill of arrival, but the calm of deep listening. Not the noise of adventure, but the peace of knowledge. And if we want to leave our galaxy someday, we must first understand why we have not yet left. We must see the boundaries clearly. We must learn the language of space, not in numbers alone, but in patience, in preparation, in awe. Because space is not an enemy to be overcome. It is a home to be understood. This understanding begins with stillness. It begins with breath. It begins here, in the quiet place between thought and sleep, where your mind is soft and your heart is open. We are not rushing through this journey. We are easing into it. Like a ship that leaves harbor slowly, carefully, we are just now beginning to untie the ropes. And as we float into this calm sea of thought, we'll explore what makes the universe so hard to cross. Each part of this story will be a gentle look at one of those truths. Not to scare you, not to stop you, but to show you the shape of the path, so that when we dream of the stars, we can dream with both wonder and wisdom. The galaxy is not keeping us here out of cruelty. It is simply holding us in place as gravity holds the moon, as the earth holds us. And maybe for now that's okay. Maybe the waiting is part of the learning. Maybe the slowness is part of the story. We are not falling behind. We are simply beginning at the beginning. So tonight, as you lie here breathing gently, you are already taking part in that journey. You are listening to the real story of space. The slow, quiet, honest story of what it means to reach beyond what we know. You don't need to move fast. You don't need to understand everything. You are already where you need to be. And as the next part begins, we'll look more closely at the first real boundary. The one that sets the pace for everything else. The boundary not of technology or imagination, but of physics. The true quiet limit of motion. The reason why, for now, the stars are still far away. Even if we solved every other problem, this one would remain. And so we move forward, not with speed but with care. Not with noise but with calm. Not with easy answers but with open minds. Slowly, gently, we begin. To leave the Earth is already a great effort. It takes powerful rockets, careful planning, and years of preparation. But even after escaping Earth's pull, we're still far from the stars. The first real barrier is distance. Not the kind we walk or fly, but the kind that stretches between suns, measured in time and light. It's not a wall we can touch. It's a space so wide that the numbers almost lose their meaning. Right now, the fastest spacecraft we've ever launched is still traveling within our own solar system. It moves quickly by our standards, tens of thousands of miles per hour. But in the language of the universe, it is slow. If it kept going in a straight line toward the nearest star, it would take longer than all of human civilization has existed. The stars do not feel close. They never have. They shine but from far away. Even if we could build a ship that travels much faster, we would still be facing the speed of light as our limit. Light, the fastest thing known to science, sets the boundary. Nothing with mass can reach it. The closer something moves toward the speed of light, the more energy it needs. The numbers don't increase steadily, they grow wildly. To move even a small ship close to that speed would take more energy than we can imagine storing. And if you imagine traveling to another galaxy, the problem grows. The distance to our nearest large neighbor, the Andromeda Galaxy, is about 2.5 million light-years away. That means even light, moving at over 600 million miles per hour, takes more than 2 million years to get there. A spacecraft would take longer, far longer. There is no machine, no rocket, no engine that can cover that distance in a single lifetime. This is not a failure. It is not something to fix with a switch or a button. It is how the universe is shaped. The stars are spread out, and light is the thread that ties them together. But the thread is thin and takes time to stretch. So we remain for now wrapped in a smaller sphere of motion. Not because we lack desire, but because space moves slowly around us and we move slowly through it. Some people ask, why can't we just go faster? And it's a fair question. But the answer is rooted in physics, not willpower. As you push an object to higher speeds, it resists. Its mass increases. It takes more and more energy just to keep going a little faster. Eventually, it becomes impossible to reach the limit. You can approach the speed of light, but you cannot touch it. It stays ahead like a shadow that never comes closer. We can imagine a road stretching across space, but it would be the longest road ever built. Every step would be slow. Every mile would be part of a journey that might never end in a single life. And this is why most missions in real life do not aim for stars. They aim for planets, moons, comets, nearby places, still within our own small corner of the galaxy. That is the space we can reach. The rest remains distant. There is no shortcut through this limit. No door hidden in the dark that lets us slip past the rules. The laws of motion apply everywhere to everything all the time. They are not broken by desire or by effort. They are calm and steady and quiet. And so, the universe asks us to be calm too. To understand what it means to live with a boundary that does not move. This also changes how we think about time. If it takes many thousands of years to reach another star, then the trip is not just a challenge of distance. It is a challenge of generations. No single person could travel that far. No single lifetime is long enough. So even if we built the perfect machine, the journey would belong to someone else, to the children of our children or their children after them. And as the distance grows, so do the chances for small errors to become large ones. A tiny change in direction at the beginning of a long journey can lead far off course by the end. The universe has no signs to guide us, no rails to follow. Once we leave the solar system, we are truly drifting. The margin for error is thin. The space around us is vast. Even if we don't think about going to other galaxies, if we only want to visit the edge of our own, it is still far beyond what we can cross in a single mission. The outermost stars of the Milky Way are over 100,000 light-years from Earth. That is 100,000 years even for light. And we are still slower than light. Much slower. That's what space asks us to understand. We may not feel these limits here on Earth. We drive, we fly, we orbit. But those are short distances. Those are playgrounds compared to the space between stars. When we launch something into orbit, it feels fast. But it is still close to home. Even the moon, our nearest neighbor, is just a few 100,000 miles away. The next star? Over 25 trillion miles from Earth. This is not a message of sadness. It is a message of truth. And in that truth there is peace. The stars are not rejecting us. They are simply waiting. Waiting in their stillness, across the light years, for a kind of journey we are not ready to take. Not yet. Maybe not ever. But maybe the waiting is part of the wonder. We are surrounded by the speed limit of light, like a soft boundary that shapes our reach. It doesn't slam into us. It doesn't fight us. It just exists. It says, this is how fast you may go. This is the pace of the universe. And everything inside it must follow. So we build, we plan, we dream, knowing that this speed remains quiet and unmoved. And even if we could ignore the limit, even if we could imagine bending the rules, we would still face the size of the journey. Speed alone is not enough. There must also be time. Time to travel. Time to live. Time to survive. And the time it takes to cross galaxies is not measured in days or years. It is measured in millennia. So as we look toward the stars, we do so not with quick steps, but with steady thoughts. The journey to another galaxy is not around the corner. It is not the next phase. It is far. Truly far. And we must hold that distance in our minds if we want to dream responsibly. To dream in a way that matches the size of the sky. We are not weak for not having arrived. We are not lost for staying near. We are learning the true size of space one step at a time. And this understanding is part of the journey. Even if we go no farther than the edge of our own solar system, we are still travelers. We are still reaching. We are still seeing what lies ahead. The stars above us remain steady. Their light travels patiently, mile after mile, year after year. It reaches us only because it never rushed. It followed the limit. It moved at the pace allowed by space. And maybe we can do the same. Maybe we can move like light, slowly, truly, and without fear. And so we continue, knowing that the first and greatest limit we face is speed itself. A speed we cannot reach. A speed that reminds us how vast the space between stars truly is. A speed that shapes every journey we can imagine. Not to punish us, not to stop us, but simply because that is how the universe is made. When we think about space travel, we often think about speed, how fast we can go, how far we can reach. But behind every motion, there is something even more basic. Before a ship can move, before it can turn or slow or speed up, it must first have energy. And in space, where distances stretch for trillions of miles, the need for energy becomes more than a detail. It becomes the center of the challenge. Energy is what powers every system on a spacecraft. It turns lights on, moves engines, keeps air circulating, and instruments alive. Without energy, a ship in space is just a metal shell floating in silence. And when the journey is long, years or centuries or more, the need for stable, lasting energy grows more important. It's not just about having enough to leave Earth. It's about having enough to keep going far beyond the edge of the known. Every time we try to move something faster in space, we need to push harder. That push requires fuel. But fuel adds weight. And heavier ships need even more fuel to move. It becomes a loop. More fuel means more mass, and more mass means more fuel again. This problem is known by engineers as the tyranny of the rocket equation. It's not just a formula. It's a hard truth about how motion works when there's no road, no friction, and no air. To escape Earth's gravity, a spacecraft must carry massive fuel tanks. The fuel burns quickly, lifting the ship only a few hundred miles above the surface. After that, most of the fuel is gone. What remains is used carefully in tiny amounts for slow adjustments and long cruises. But when we think about reaching other stars, we imagine trips that would need far more than a short burn. They would need engines that can last for decades or even centuries. There are ideas for future engines, nuclear, electric, or using particles from space, but all of them face the same problem: how to carry, gather, or convert enough energy over time without making the ship impossibly heavy. Traditional fuel, like the kind used in rockets today, burns fast and is used up quickly. It's fine for short trips, but it doesn't scale well for long journeys across space. It runs out far too soon. To travel far, the energy source must be dense. That is, it must store a lot of energy in a small space and weight. Gasoline is energy dense compared to batteries, but nuclear fuel is far denser than both. That's why scientists think of using nuclear reactors in space. They last longer and carry more energy per pound. But even then, they have limits. They still run out. They still produce heat. And they still come with risks. Heat in space is not like heat on Earth. Here we cool things by moving air across them. But in space there is no air, no wind, no fans. The only way to get rid of heat in space is by radiation, by letting the heat slowly drift away as invisible light. That process is very slow. So every engine, every system that runs in deep space, must deal with waste heat building up. If the heat isn't removed, the ship will overheat. This might not seem important at first, but over years and decades, heat becomes a serious challenge. Power plants on Earth use massive cooling towers and rivers of water. Spacecraft have no such options. They rely on radiators, large panels that release heat into space. But radiators are heavy and fragile. They take up space, and the more energy you use, the more heat you must remove. It's a quiet problem, but it's one that never goes away. Even solar panels, which seem clean and simple, have limits. They only work near a star. As you move farther from the sun, the light gets weaker. At the edge of the solar system, sunlight is only a tiny fraction of what it is near Earth. Beyond that, there's almost nothing to gather. The panels become less useful. And nuclear batteries, like those on the Voyager probes, decay slowly over time, losing power year by year. So a long journey through deep space isn't just about how to move, but how to power everything while moving. Lights, computers, heaters, guidance systems, all need energy. And the farther you go, the harder it is to resupply or recharge. There are no gas stations in interstellar space. No repair shops. No refueling points. Everything must be brought with the ship, planned from the start. This makes energy a kind of clock. A quiet countdown. Once your source runs out, the ship goes dark. It stops sending signals. It becomes cold, quiet, and still. It doesn't crash, it just freezes in place, like a candle that has burned down to the end. The longer the journey, the more you must prepare for that moment. The end of energy is the end of life for a ship in space. And the more energy you try to bring, the heavier the ship becomes. Heavy ships need more thrust to move. More thrust needs more energy. And so the cycle continues. You try to solve one problem, but it makes another problem worse. This is the balance that space missions must face every time they go farther. Every pound of fuel must be worth its weight. Every system must earn its place. Engineers dream of more efficient systems, of engines that burn nothing, of sails pushed by light, of magnetic fields that scoop particles from space. These are not impossible, but they are not ready yet. And even if they were, they would still face the same quiet truths. Space is cold, dark, and empty. Energy must come from somewhere. And waste heat must go somewhere else. Some ideas use the sun itself, giant sails that catch sunlight like wind. These can move slowly, gaining speed over time without fuel. But they still need time. And they only work when close to light. Beyond the stars, there is no sun to catch. Others dream of beaming energy to ships using lasers or microwaves from far away. But aiming those beams over trillions of miles is a challenge we don't yet know how to solve. The deeper we go into the problem of energy, the more we see its shape. It is not a wall we can break. It is a weight we must carry. Every mile traveled, every hour survived depends on how wisely we manage power. Even small systems, a heater, a computer, a pump, can become life or death when energy is limited. And in space, energy is always limited. Some missions use backup systems, batteries that kick in if the main power fails. Others shut down parts of the ship to save power, waking up only at intervals to send data. These tricks help stretch the journey, but they are still bound by the same end. When the fuel is gone, the mission is over. And in deep space, that end comes slowly but surely. Even the Voyager probes, now in interstellar space, are nearing the end of their power. Their small nuclear batteries are growing weak. Soon, even the last instruments will go dark. The signal will stop. The spacecraft will continue to drift, but they will no longer speak. They will become quiet travelers, carrying their golden records in silence across the stars. So when we talk about going beyond our galaxy, we must also talk about energy. Not as a dream, but as a supply. As a need. As a weight. We must ask, how long will it last? How will we store it? How will we cool the ship? How will we live in the dark? These questions may not have easy answers, but they guide every part of the mission. And maybe that's the lesson space teaches us. Not just about how to move, but about how to care for what we carry. Every watt of power matters. Every drop of fuel has value. And every system must be built not just to work, but to last. To survive the silence. To endure the cold. To keep going mile after mile with no help and no return. In the stillness of space, energy is more than motion. It is warmth. It is breath. It is life. And without it, even the most advanced ship becomes only metal and silence. So we must learn how to travel not with speed alone, but with care, with balance, with patience, slowly, wisely, forward. When we dream about sending people into deep space, we often picture the ship first. We imagine the engines, the walls, the glowing lights, the stars passing by. But behind that image is something quieter, more personal, and more fragile. We imagine the people inside, living, breathing, sleeping. And for them to survive, the ship must become more than a vehicle. It must become a home. A home in space is not just shelter from the cold or protection from speed. It is a closed world. Nothing enters. Nothing leaves. Every breath, every sip of water, every bite of food must be planned in advance or produced inside the ship. On Earth, we live with air all around us, water in lakes and clouds, and food grown in fields. But in space, every element must be recycled. Nothing can be wasted. The first need is air. Every person breathes oxygen and exhales carbon dioxide. On Earth, plants turn that carbon dioxide back into oxygen. But in space, without open air and forests, we must create that cycle ourselves. Machines can pull carbon dioxide from the air and release oxygen again, but those systems must work perfectly. A small failure over time can make the air unsafe to breathe. And if it breaks, there is nowhere else to go. Water is just as critical. Humans need water to drink, to clean, to cook, to grow food, and to stay healthy. On Earth, water flows in rivers and falls from the sky. But in space, water must be reused over and over again. Every drop must be collected: steam from the air, sweat from the skin, even water from breath and waste. It is filtered, cleaned, and returned to be used again. There is no fresh supply, only careful recycling. Food presents a slower but equally important challenge. In short missions, astronauts eat packaged meals, dried, sealed, and measured. But for long-term journeys, food must be grown. Plants can provide not just nutrition, but also help clean the air and recycle water. Still, growing food in space is hard. There is no soil, no rain, no seasons. Everything depends on artificial light, temperature control, and careful balance. This means that the life support system, the quiet machines behind the walls, must do more than one job. They must handle the air, the water, the temperature, the light, and the waste. They must run without pause for years, decades, maybe even longer. And they must be stable. Not just in the beginning, but over time, through the wear and tear of daily life in space. On Earth, we often take systems for granted. Something breaks, we fix it. Something runs out, we buy more. But in deep space, nothing is nearby. A failed system cannot be replaced by a delivery. Spare parts may be limited. Tools may be simple. And knowledge must be shared among the crew, not sent from mission control, which may be years away by message. And so, every part of the life system must be designed with great care. Not just for function but for endurance. Each fan, each filter, each line of code must be trusted. It must run in silence, behind the scenes, for as long as the mission lasts. Because human bodies do not pause. They keep breathing, sweating, kneading. And space does not forgive gaps in planning. Over time, even small problems grow. A small leak in a pipe. A drop in air pressure. A slight error in water recycling. On Earth, such things might go unnoticed or be quickly repaired. In space, they can become emergencies. So the crew must not only live but maintain the systems that help them live. Their hands are not only for steering, they are for survival. And as the years pass, new problems may appear. Materials wear down. Pipes crack. Filters clog. Software may need updates. Batteries may fade. And all of this must be handled from inside, without a team of experts nearby, without a warehouse full of tools. Everything must be planned with enough flexibility to adapt, enough strength to endure, and enough backups to recover from failure. Isolation makes these needs sharper. A life support system must also protect against the unknown. What if a comet dust cloud damages the outside? What if a power dip causes a freezer to shut down? What if a disease spreads inside a closed space with no hospital? The risks are quiet, but they are real. Life support must think ahead. It must prevent, not just fix. In the end, supporting human life in space becomes more than just machines. It becomes a pattern, a way of living carefully. A balance between need and supply, between comfort and risk, between effort and rest. And this balance must be held not for a day or a week, but for years. For the entire time the crew is away from Earth. Possibly for the rest of their lives. The space station orbiting Earth today already teaches us part of this story. Astronauts there breathe recycled air, drink purified water, and grow small amounts of food. They work on machines daily. They fix pipes, test systems, report problems, and carry out repairs. And even with all that care, they rely on regular supply missions. In deep space, such supplies would not exist. So as we dream of going farther, we must also dream of living differently. With more care. With more awareness. With systems that can handle months or years without contact. With backups for backups and habits that keep everything running. The life of the ship and the life of the crew are the same. If one stops, so does the other. And the longer the journey, the more that reliability matters. Not just strength but calm. Not just power but grace. Machines that hum softly without fail. Systems that can be cleaned, adjusted, repaired by hand. And people who understand them deeply, not just how to use them but how to keep them alive. Because the air they breathe is borrowed. The water they drink is shared. The food they grow is part of a cycle. There is no room for waste, no space for mistakes that can't be undone. Everything must flow like breath, in and out, over and over without pause. That is the quiet art of surviving in space. So when we think of life support, we must think of more than machines. We must think of time. Of long stretches of stillness. Of months where nothing changes and systems must still work. Of years where the crew depends on the same air, the same water, the same gentle rhythm. That is what makes the difference. And in this rhythm we find a new kind of living, not faster but wiser. Not heavier but lighter. The kind of living that listens to every sound, notices every drop and respects every resource. The kind that could last across the long silence between the stars. The kind that could keep people alive far from home. So when we look at a spacecraft and imagine it flying through the dark, let us also imagine the breath inside. The careful hum of machines. The warmth of growing light. The quiet recycling of life. All of it balanced. All of it working. All of it gently holding the future in place. Because space is not kind, but it is patient. And to live there we must be patient too. Out in space, far from the Earth's magnetic field and thick atmosphere, there is no natural shield. There is no sky to soften the light, no ground to hide beneath, no blanket of air to stop invisible particles from passing through. Every spacecraft that leaves Earth must carry its own protection because space itself is filled with quiet dangers that we cannot see, but that are always there. These dangers do not make noise. They do not glow. They pass silently but with great power. One of the most constant challenges is radiation. On Earth, we live beneath a protective bubble. The planet's magnetic field deflects many of the particles that come from the sun and beyond. The atmosphere absorbs the rest. But in deep space that protection is gone. The particles move freely. They come from stars, from solar flares, and from far beyond our galaxy. Some travel for millions of years before reaching us. Most of this radiation takes the form of very small, very fast particles. They move close to the speed of light. Some come from our sun, especially during solar storms, when charged particles are sent flying outward in a burst. Others are called cosmic rays and they come from much farther away, from exploding stars, from black holes, from violent events that shape galaxies. These particles are tiny but they carry immense energy. When they strike a person or a machine they can pass straight through or collide with atoms, breaking them apart. Inside the human body they can damage cells. Over time this damage builds. It increases the risk of cancer and other long-term health problems. It also affects the brain, the heart, and the blood. And unlike on Earth, there is no shelter just around the corner. Out in deep space you are always exposed. A spacecraft must try to shield its crew. But shielding is not simple. It is not like adding a thick wall and being safe. Radiation is complex. Some particles can be stopped by metal. Others pass through it. Some shielding materials create more radiation when struck. The best shields are often made of hydrogen-rich substances, like water or plastic, because they absorb energy more gently. But these materials are heavy. And every pound of shielding adds weight to the spacecraft. More weight means more fuel. More fuel means more energy. So each decision becomes a trade. How much protection is enough and how much weight can the ship carry? There is no perfect answer. Too little protection and the crew is at risk. Too much and the ship may never leave the launch pad. This is one of the quiet calculations that shapes every long journey. Even the International Space Station, orbiting just a few hundred miles above Earth, deals with radiation. The astronauts there receive more exposure than people on the ground. But they are still within Earth's magnetic field. In deep space, on the way to Mars or beyond, the levels would be much higher. And on a journey that takes years, the exposure adds up little by little like sand filling a glass. Solar events are harder to predict. The sun can seem calm, then suddenly release a burst of energy, a solar flare or coronal mass ejection. These events send streams of particles racing through space. If a spacecraft is nearby, those particles can arrive in minutes or hours. Some missions include shelters, small shielded spaces inside the ship where the crew can hide during a storm. But not every ship has one, and not every storm is known in time. Cosmic rays are harder still. They don't come from one direction. They are not part of a cycle. They arrive from all over all the time, passing through walls, passing through bodies. They are slower to do harm but more constant. There is no way to escape them completely, only to reduce their effect. In this way they become part of the background of space, always there, always moving. Machines also suffer. High-energy particles can pass through electronics, changing bits of data, flipping switches, causing glitches or even failures. Spacecraft must use special parts that are hardened against radiation. Systems must include backups. Software must be able to reset and recover. Even a tiny change, invisible to the eye, can cause large problems over time if not managed carefully. The deeper we go, the more radiation we face. The farther from the sun, the less solar protection we have. And the farther from Earth, the less help we can call for. That's why missions to other planets or to the edge of the solar system require extra thought. Not just for how to fly, but how to live under a quiet, invisible rain that never stops falling. Some people wonder, can we just build ships with thick walls like bunkers? In theory, yes. But in practice, the mass becomes too great. A spacecraft must balance strength with movement. It must be strong enough to protect but light enough to launch. So engineers try other methods. They place sleeping quarters in the center where shielding is thickest. They store water and supplies around the walls, letting those act as a buffer. Every piece of the ship plays a role. And some think of even more creative ideas, using magnetic fields or charged particles to build invisible shields like Earth's. These ideas are promising, but they are still in early stages. They need energy, stability, and testing. They may work one day. But for now, physical mass, materials placed between people and space, is still the main defense. Radiation is not loud. It does not feel like a storm. It does not shake the ship or make alarms ring. It passes quietly. But over months and years, its effects build. That's what makes it difficult. There is no moment when everything changes. There is only slow exposure. And that slow exposure is part of every long trip beyond Earth. So when we plan to visit Mars or to travel farther, we must include this invisible risk. We must design ships that can protect without becoming too heavy to fly. We must give crews safe places to rest. We must measure and monitor with sensors and alerts. And we must accept that some risk remains. There is no way to remove it completely. And maybe that's part of the message space gives us. That not all dangers are loud. Some are silent. Some move through us without notice. And yet, with planning, with patience, with understanding, we can live with them. Not by ignoring them, but by respecting them. By learning their patterns. By building in harmony with what space offers. Radiation teaches us humility. It reminds us that the universe is filled with forces beyond our control. Not angry, not cruel, just present, just real. And it invites us to think carefully, to design wisely, to prepare not for battle but for balance, not to fight space but to move through it gently. Because space does not bend to our wishes. It simply is. And in that stillness, in that exposure, we are asked to grow. To see not just the stars but the space between them. The particles that pass unseen. The energy that travels across the dark, not to harm but simply to be. And so, as we float through the galaxy, as we imagine ships moving slowly between suns, we also imagine the quiet armor they must carry. Not sharp, not thick, but steady, reliable. Just enough to let life continue. To let hearts keep beating. To let minds stay clear. That is what shielding really means. Not walls but care. Not fear but foresight. Not perfection but planning. Slowly, gently, forward. In space, distance is not the only thing that stretches. Time also bends, slowly and silently, as you move farther and faster. We don't feel it on Earth. Time seems steady here. Seconds pass evenly, days follow nights, and years flow forward in a rhythm we've known all our lives. But the universe doesn't measure time the way we do. It flows differently when you move fast or when you are far from a planet's gravity. This change is called time dilation. It is not science fiction. It is real. Imagine two clocks. One stays on Earth. The other is placed aboard a fast-moving ship that travels through deep space. At first, both clocks tick at the same pace. But as the ship picks up speed, especially if it approaches a significant fraction of the speed of light, The clock on board begins to slow down. Not because it's broken. Not because something is wrong. But because time itself is moving differently in that frame of motion. When the ship returns, the two clocks will no longer agree. To the person inside the ship, time still feels normal. Minutes feel like minutes, days feel like days. But outside that ship, more time is passing. The earth continues to turn, seasons change, and years move forward faster. This is one of the strange, beautiful truths of physics. Speed does not just affect space, it touches time as well. And the faster you go, the more time bends around you. It's not something we notice in airplanes or cars, but in space, across great speeds and great distances, it begins to matter. If a crew left Earth and traveled near the speed of light, they might only experience a few years of life aboard their ship. But by the time they returned, or if they could ever return, many decades, even centuries could have passed back home. Family would be gone. Cities would have changed. Languages might shift. The world they left would no longer be the world they returned to. They would become, in a quiet way, travelers not just through space but through time. And not all time delay comes from motion. Some of it simply comes from distance. Light, as fast as it is, still takes time to travel. And in space, where nothing is close, that delay becomes very real. A signal sent from Mars can take up to 20 minutes to reach Earth. From the edge of the solar system, it takes hours. From another star, it could take years. There is no way to make that go faster. It is part of the structure of the universe. This delay means that deep space missions cannot depend on real-time conversations. There is no instant back and forth, no live instructions, no quick help. The farther out you go, the more alone you are, not just in space but in time. Communication becomes slower, quieter, more like writing letters than making calls. You speak, then wait, and eventually you may hear a reply. This changes how missions must be planned. Every message must be thoughtful. Every decision must be made in advance. Every crew must be trained not just to follow directions but to think, to adapt, to lead. Because help may be far behind. And in some cases, it may never arrive. The separation caused by time is not always something you can fix. It becomes part of the mission itself. And for those who stay behind, time feels even more different. Loved ones left on Earth grow older while the traveler may age slowly. Children become adults. Stories unfold. History moves on. The traveler, moving fast and far, becomes a visitor from another time, someone who steps out of the ship and into a future they never lived. The world may not be the same, and they may no longer belong to it. This is a quiet cost of space travel. Not just the danger, not just the distance, but the loss of shared time. The crew may leave together, but return to a world that has moved on without them. It is not dramatic. It is not loud. It is slow and subtle. A change in rhythm. A change in connection. Something soft and deep, like the space between heartbeats growing wider. Relativity is the name we give to these changes. It was described over a century ago, and it still shapes how we understand motion and time. The faster you go, the slower time moves for you. The deeper you are in gravity, the slower it flows as well. These effects are tiny in daily life, but across the distances of galaxies, they become large. They stretch seconds into minutes, years into lifetimes. And there is no way around them. Even our GPS satellites, circling Earth just a few thousand miles above us, must adjust for time dilation. Their clocks tick slightly differently from ours. If we didn't correct for that, our maps and systems would quickly drift out of sync. Now imagine a ship traveling millions or billions of miles away. The corrections needed grow larger. The effect of time becomes something you must plan for, build around, and live with. This teaches us that time and space is not a line. It is not steady. It is a field that moves and bends depending on where you are and how you travel. This doesn't mean that time is broken. It just means that time is part of space. Not something outside of it. Not separate. But woven together like light and shadow, dancing across the fabric of the cosmos. And so, when we dream of traveling far, we must dream of letting go, not only of Earth but of the time we share with it. We must accept that deep space travelers will see fewer birthdays, while those on Earth see many more. That messages will arrive late. That voices will come from the past. That reunion, if it happens, may feel like stepping into a memory someone else lived. None of this makes space travel impossible. But it makes it different from what we often imagine. It is not just a path through distance but a path through time. Not just a journey across miles but across change. And that change is slow. It is constant. It is gentle but permanent. Like footprints left in sand that time never smooths away. In this way the traveler becomes a witness. They carry the present into the future. They bring with them the world as it once was. They become a link not just between places but between moments. And that link is fragile. It must be held with care. Because once you move at great speed, once you travel great distance, the clock you carry no longer matches the clocks you leave behind. This difference can be lonely, but it can also be beautiful. It means that every journey through space is a kind of time capsule. Every traveler becomes part of a longer story. Not just one of motion but of memory. A quiet bridge between the now and the then. Between the Earth of today and the one that may come tomorrow. So when we build ships for deep space we must build not only for heat and pressure, not only for fuel and shielding but also for time. We must understand what it means to live with delays. To wait for replies. To return to a world that may not remember the moment you left. That is part of the truth we carry into space. And maybe, in the end, that's what space teaches us about time. That it is not ours to hold tightly. That it moves whether we watch or not. That the universe is older than us and will outlast us. And that when we move through it, we are touching not just stars but history. Not just space but time itself. The stars above you tonight may no longer exist. Their light has traveled for hundreds, sometimes thousands, of years to reach your eyes. You are not seeing them as they are now but as they once were. Space is not just far, it is full of memory. Full of light from the past. Full of quiet echoes from before we were born. When we think about a journey through deep space we often imagine the ship itself. The engines, the fuel, the people on board. But behind all that is something quieter, something just as important. A direction. A path. A way to know where you are and where you're going. Without that even the most powerful ship would drift endlessly, lost in the dark. Navigation is not just about motion. It's about meaning. It's what gives the journey shape. On Earth we have maps, roads, signs and satellites to guide us. We can see the land, feel the air, use landmarks to find our way. But in deep space there are no signs. There are no roads. There are no visible paths. The stars are distant points, and they do not move fast enough to help us guide a ship in real time. Once you leave Earth's orbit, you are on your own. Every mile traveled must be measured carefully. Every course correction must be done without mistakes. The farther you go, the more precise your navigation must become. A tiny error in direction, a shift of just a fraction of a degree, can send a ship thousands or even millions of miles off course over time. It's like throwing a dart from one side of the country to the other and hoping it lands in a cup. A small miss at the start becomes a huge miss in the end. And in space, where destinations are often invisible, there is no easy way to turn around. Navigation in space relies on a mix of math, sensors, and trust. The ship uses gyroscopes to sense its own rotation. It uses star trackers, special cameras that recognize patterns in the sky, to know its orientation. It uses radio signals sent across billions of miles to calculate how fast it's moving and in what direction. But all these systems must work together. And they must keep working not just for a day or a week, but for years, for decades, maybe even longer. This is where reliability becomes more than a goal. It becomes a requirement. Every part of a spacecraft, every wire, every chip, every piece of software, must survive the long journey. Not just survive the launch, but endure the deep cold of space, the quiet radiation, the passing years. The systems that steer the ship must keep steering. The ones that measure must keep measuring. There are no restarts, no mechanic nearby. The ship must care for itself. Redundancy becomes a key principle. That means having more than one way to do the same thing. If one computer fails, another can take over. If one sensor drifts out of alignment, a backup can correct it. If a part wears out, another may already be in place. Redundancy doesn't stop failure, it absorbs it. It allows the mission to continue even when something goes wrong, which over time, something always will. But redundancy adds weight. It adds complexity. Every backup system is a choice. What to duplicate, what to simplify, what to protect. There is no way to prepare for every possible problem. So designers choose what matters most. Life support, power systems, navigation, communication. These must last. These must be strong. These must not fail quietly. Even the smallest part matters. A loose wire, a cracked lens, a drifting sensor. These can go unnoticed for days, weeks, even years. But over time they can lead to deeper errors. A ship that turns too slowly, a signal that fades too soon, a computer that starts guessing wrong. In space, problems don't always shout. They whisper. And if no one hears them, they grow. That's why some ships are designed to diagnose themselves, to run checks, to compare data, to reboot when needed, to keep logs and watch their own health. These systems are like a kind of memory, a quiet intelligence that keeps the ship aware of its own condition. Not smart like a person, but careful, watchful, able to notice when something no longer fits the pattern. But even with all these tools, navigation over long timescales still carries risk. Stars move, gravity shifts, dust clouds appear, instruments age. Software written decades before may not behave the same. And over 100 years, the space around a ship can change. The map itself may evolve. And the ship, unless it can learn, will not know. It will continue unaware. That's why some dream of building ships that think for themselves, that adapt, that learn. Not in a human way, but in a quiet, steady way, correcting their path, checking their health, choosing the next step. These are not ships of fiction. They are not magical. They are machines with patience, with sensors and memory, with the ability to continue even without contact. Because contact too is not guaranteed. The farther a ship travels, the harder it becomes to speak with it. Signals take longer. They grow weaker. The dish on Earth must point precisely. The ship must aim carefully. And even then, the message may be delayed by years. So the ship must navigate, at least in part, without help. It must trust its own senses. And it must do so for a very long time. Voyager 1 is a quiet example. Launched in 1977, it still sends data. Still listens. It still steers its antenna toward Earth. But its systems are aging. Its computers are old. Its sensors are fading. One day it will go silent. But it will continue moving. A quiet traveler. Alone but still on course. And that is the dream of deep space navigation. To stay on course even in silence. And this idea shapes every future ship we may build. To leave the solar system. To enter interstellar space. To fly not for months but for centuries. Not with people aboard, perhaps, but with messages, memories, instruments. These ships must hold their course through dark regions we have never seen. Through fields of dust. Through gravity from stars. Through the great, slow dance of the galaxy itself. They must not forget their goal. They must not lose direction. Even when no one is watching. Even when Earth has changed. That is what reliability means. Not perfection but persistence. A gentle endurance. A ship that remembers. A ship that adjusts. A ship that carries its mission in every part, from engine to edge. And as we imagine crewed missions with people aboard for years or lifetimes, reliability becomes even more human. The ship must feel like a home that does not betray its guests. A place where systems don't just work but stay working. Where air flows and lights glow and tools do what they promise. Where life continues not by magic but by care. Because in deep space, there is no margin for forgetfulness. A missed update, a flawed sensor, a forgotten battery. These are not just inconveniences, they are turning points. So we must design not just for performance but for time. Not just for power but for peace. For quiet systems that last. And maybe this is one of the most humbling lessons space gives us. That the longest journeys are not won by strength alone. They are sustained by memory, by checks and double checks, by backups and patience, by the slow, steady work of machines doing their job, hour after hour, mile after mile, without fail. So when we imagine a ship crossing the stars, let us also imagine the hidden layers inside it. The quiet software, the gentle spin of a gyroscope, the careful hum of a clock that keeps time not for weeks but for centuries. Let us imagine not just speed but staying true, not just motion but memory. A spacecraft may be built with strong walls, stable power, and systems that run for years without fail. But inside those walls are people, breathing, thinking, feeling. No matter how advanced the technology, it is the human experience that shapes the journey. And that experience depends on more than food and air. It depends on peace of mind, on steady emotions, on finding meaning in each day while floating through a place with no horizon. Life in space is not like life on Earth. There are no open skies, no fresh air, no trees, no rain, no natural change. The environment is controlled and the space is small. On long missions, especially those that last for years or even decades, the inside of the ship becomes the whole world. The same walls, the same rooms, the same faces. And though these may be carefully chosen and beautifully designed, they can still become heavy with time. The mind needs variety. It needs change. It needs a rhythm that includes something new, something unexpected. But in deep space, every day can feel the same. The ship moves forward, but there is no window view that changes, no landscape passing by. Outside, the stars remain fixed. Inside, the routines repeat. Sleep, eat, work, rest. And while routine is helpful, too much sameness can lead to a quiet emptiness. That emptiness is not loud. It does not arrive all at once. It grows slowly like a shadow. A small sense of restlessness, a feeling that something is missing. Over time, it can grow into sadness, into confusion, into anxiety, or even anger. These feelings are not failures. They are natural responses to isolation, to living in a place where the usual signs of life are absent, where the earth and everything it holds is far behind. People need connection, not just messages or orders, but emotional closeness. The kind that comes from shared time, eye contact, touch, laughter, and comfort. In deep space, this connection is harder to hold. Communication delays make conversation slow. Families and friends on Earth move on with their lives. Time passes differently. And even though the crew is not alone, they can still feel lonely. Living in close quarters with the same people can also be challenging. There is no place to go for a walk alone. No privacy beyond a curtain or a small room. Every sound carries. Every disagreement lingers. And even with training and respect, tension can build. People see the same faces every day. Voices repeat. Habits become more noticeable. And patience becomes one of the most important tools on board. To stay well in space, the mind must adapt. It must find peace in repetition. It must make space inside itself when there is no space outside. Astronauts learn to focus on small routines, to care for plants, to write, to listen to music, to exercise, to meditate. These habits become anchors. They mark time. They give shape to the days. And they remind the crew that life continues even in the silence. Exercise is especially important, not just for the body but for the brain. Moving the body helps release tension. It improves mood. It brings energy to the day. In space, exercise is also needed to keep muscles and bones strong, since there is no gravity to do that work. But beyond health, it gives people a moment to feel alive, to feel change, to feel themselves in motion. Sleep, too, becomes precious. Without the rising and setting of the sun, the body must find its own rhythm. Lights are used to create a sense of day and night. Sounds are managed. Schedules are followed. But still, the brain can struggle. Dreams may become vivid. Sleep may come at strange times. And the quiet hum of the ship may feel endless. Rest becomes not just physical but emotional, a time for the mind to settle. Stories and memory become even more valuable in space. People carry with them books, photos, music, and videos from Earth. These are not just entertainment. They are bridges. They connect the crew to something larger, to the world they left, to the lives they remember. A single song can feel like a visit home. A video message can bring tears. A written letter sent years ago can offer new strength on a hard day. Psychological support is part of every long mission. Crews are trained to recognize signs of stress, to talk openly, to support each other. Some missions include private talks with counselors back on Earth. Others use journals, group meetings, or daily check-ins. These tools help create emotional safety, not just for one person but for the group. Because in space, a crew is more than a team. It is a shared mind. Some people imagine that astronauts are always brave, always focused, always ready. But in truth, they are human. They feel fear, frustration, doubt, and homesickness. What keeps them strong is not the absence of emotion, but the presence of trust. Trust in each other. Trust in the mission. Trust in the small habits that make up each day. The rhythm that becomes life. And in this rhythm, new meaning can be found. The quiet of space invites reflection. It opens a space inside the self where thoughts can stretch. Questions rise. What matters? Why am I here? What is home? These are not problems to solve, but paths to walk. In the stillness of deep space, many find a deeper sense of purpose. Not in the stars outside, but in the journey within. Time also changes the crew. The person who left Earth is not the same person who will return. When the crew finally returns, if they return, the Earth may feel strange. The sky too open. The ground too loud. Crowds too close. The mind must readjust again. It must find balance between what it learned in space and what it now sees on Earth. And this readjustment, like the mission itself, takes time. Patience, care, support from others, a slow return to shared life. For those who never return, who go on one-way journeys or journeys that last a lifetime, the mental world becomes even more important. Space becomes not just a place they pass through, but a place they live. And in that living they create a new kind of home. Not built with wood or stone, but with routine, connection, thought, and memory. A mental architecture shaped by time. So when we think about deep space travel, we must think about more than systems and engines. We must think about the people inside. How they wake, how they rest, how they keep going. Not just in body but in heart. Because in the end, the mission only succeeds if the people inside are whole. If they are supported. If they are given the tools not just to survive but to live. And maybe that's the quiet truth space offers us. That the farther we go from Earth, the more we must care for what is human. Not just the bones and the blood, but the mind that dreams, that remembers, that hopes. The part of us that needs music. The part that misses rain. The part that listens for the voice of a loved one across the long silence. Sometimes, when you sit quietly and let your thoughts drift upward, it's hard not to feel the size of everything. Not in a way that frightens, but in a way that opens you. The stars are not just decorations in the sky. They are suns, each one vast, each one older than anything we know, each one burning across time and distance beyond what our eyes can fully see. And between them is a silence so wide and deep that it becomes a kind of comfort, a stillness we can rest in. Out there, beyond the lights of our cities, beyond the thin line of our atmosphere, the universe stretches with quiet patience. It holds galaxies the way the ocean holds islands, scattered, floating, alone but part of something larger. And our own galaxy, with its spiraled arms and glowing clouds, is just one among billions. The scale of it all is not a challenge. It is not something we must rise above. It is something we are allowed to witness. The Earth we live on is small, but it is not less for that. The size makes it precious. From far away, it is a blue-white dot, soft and glowing, wrapped in a thin skin of air. It holds everything we've ever known, every tree, every song, every hand held in love. It floats in the dark not with fear but with grace. Like a candle left burning in a still room. Like a memory that never fades. When we look up at the stars, we are not looking out. We are looking in. We are seeing the place we came from, the place our atoms once lived, the fires that made us. Every part of our body, every cell, every breath, is made from elements forged in stars. We are not visitors to the universe. We are part of it. Not outside it, not separate, but within it entirely. There is comfort in knowing that. Not as a fact to memorize, but as something to feel in your chest. That we belong here. That the universe is not a stranger, but our home. Not a storm, but a garden of time and light and space, growing slowly in all directions. There is no race to win, no edge to reach. There is only this unfolding, this opening, this quiet movement through being. In the great stillness of space there is no rush. Stars are born, live, and die over billions of years. Galaxies drift apart slowly, like leaves on a gentle current. Everything that moves does so in long rhythms, deeper than our days, slower than our lifetimes. When we feel small, it is not because we are unimportant. It is because the universe is patient. It waits without hurry, without judgment. That kind of time invites a softer kind of thought. Not about what we will achieve, but about what we will witness, what we will notice, what we will remember. Even our longest missions, even our boldest ships, are only tiny sparks in this darkness. They do not need to go far to be part of something vast. They only need to go honestly, with care and with wonder. There is beauty in knowing we are not the center, that the universe does not revolve around us, that stars shine whether or not we see them, that planets orbit in silence, that comets pass quietly across the black. We are part of this beauty. We are not masters of it. We are not its purpose. We are its observers, its witnesses, its quiet companions. And in that role there is peace. We do not need to conquer. We do not need to own. We do not need to go faster, louder, brighter. We can simply be. To sit on a ship and watch the stars pass. To breathe slowly as the galaxy turns. To listen to the hum of space not as a problem to solve, but as a song we are lucky to hear. A long, slow melody written in light. Even the deepest questions, why we exist, what life means, what lies beyond, can be held more gently in this space. Not answered perhaps, but respected, allowed, given room. The universe does not tell us what to think. It offers us silence and invites us to bring our own meaning. It does not demand anything from us. It simply opens. So when we imagine traveling beyond our galaxy, we are not imagining escape. We are not imagining conquest. We are imagining reaching out with an open hand. Not to take but to feel. Not to prove but to witness. And maybe to understand a little more about ourselves by stepping into the quiet that holds everything. Because the more we learn about space, the more we learn about ourselves. That we are fragile. We may never leave our galaxy. And that's okay. We don't need to go far to feel part of something infinite. We only need to pay attention. To notice the light, to feel the rhythm of breath, to remember that the atoms in our hands once drifted through stars, that even as we sleep, the universe continues, turning, unfolding, glowing, without us and with us. So if you're lying here now, resting, listening, breathing, you are already part of that rhythm. You are part of the stillness. You are part of the deep quiet between galaxies. The same quiet that lives in space also lives in you, in the slow beat of your heart, in the gentle rise and fall of your chest, in the silence between thoughts. This kind of awe is not loud. It does not shout. It does not shake the ground. It arrives like the evening sky, wide, soft, and full of stars. It does not ask for anything. It offers a place to rest, a space to wonder, a reminder that you are already home even when you are far away. In space there is no up or down, no right or left, no beginning, no end, just distance and time, just change and light, just the slow unfolding of everything. And in that unfolding we find room to breathe, room to wonder, room to simply be. So now we've traveled together through the quiet shape of space, not fast, not loud, but slowly and gently, letting each idea unfold. We have floated past engines and fuel, past time and silence, past light and thought. We did not rush. We did not force. We let the story of the stars speak in its own way, in its own time. And somewhere in that stillness, your thoughts may have softened. Your breath may have slowed. And the day behind you may already feel far away. We began with a single image, a spacecraft, alone, drifting through deep space. Not toward a war, not toward a battle, not chasing a prize, but simply moving with purpose and calm across the vastness between stars. From that image, we opened up the truth of our limits. We saw how hard it is to move far. Not because we lack dreams, but because the universe is wide and its rules are patient. We saw that speed has a cost. That every step away from Earth carries more weight. That fuel runs out. That heat builds. That air must be cleaned and water must be reused and people must be cared for, not just in body but in heart. We saw that even perfect machines are not enough if they do not last, if they do not adjust, if they do not endure the long silence. We looked at radiation and time, at memory and separation, at the way space bends not just direction but time itself. We followed that thought through the long loneliness of a journey without answers, into the space of the mind where people must create their own light. And in the end we found ourselves not in fear, but in awe, in wonder that we are here at all, that we can look up and dream. And maybe that's what this journey was really about. Not reaching another galaxy, not solving every problem, but learning how to sit with what is true, learning how to be small without being afraid, learning how to be slow without feeling left behind, learning how to rest in the rhythm of something older and larger than ourselves. The stars above us tonight are still burning. The space between them is still wide. But so is the space inside your breath, inside your chest, inside your thoughts. You don't need to leave this planet to feel the vastness. You don't need to build a ship to hear the silence. You only need to pause, to listen, to allow the deep quiet to rise up and meet you. And that's what we've done here, together in this space made of words and breath. We've let the universe move not through rockets or engines but through stillness, through slow ideas, through gentle attention. And if, somewhere along the way you drifted toward sleep, that too is a kind of travel. That too is a kind of letting go. There is nothing more to reach for tonight. No more questions to answer. No problems to solve. All that's left is the quiet curve of your thoughts settling. The feeling of weight returning to your body. The long exhale of a mind allowed to rest. You are already where you need to be. You are already held, already carried, already safe. The spacecraft still drifts. The stars still shine. Time still moves. But you are here and that is enough. Maybe you will sleep soon. Maybe you already have. Either way, this story will hold you until the end. It will keep going, soft and slow, even as you slip deeper into rest. Because the universe is still unfolding. And you are part of that, whether waking or dreaming. So as we come to the final stretch of this journey, let the last few words fall gently. Let them land like snow, like starlight, like a soft breeze passing through a quiet room. Let them carry no weight. Let them ask for nothing. Let them simply be what they are, just sound, just rhythm, just space to breathe. Tonight is not about answers. It's about trust. Trust in silence. Trust in time. Trust that even in a galaxy we may never cross, we still belong. That we are still held. That our dreams, like the stars, don't need to be touched to be real. They shine anyway. They shine just by being. Thank you for spending this time here. If this helped you rest, or helped you reflect, or helped you simply feel calm for a while, you're welcome to return whenever you need. You can follow or save this or just come back when the sky feels a little too wide. There's no rush. There's no pressure. Just slow breath and quiet space.